Now, before we dive into the course content, I'd like to give you a teaser or taste of what you'll be able to do by the end of the course. Now, usually in my teaser lectures, I'd give one example to show students what they'll be able to do once done with the course. But in this course, you're going to learn so many cool things, and we're going to build more than 20 hacking tools. So it's unfair and it's really hard for me to pick only one example. Therefore, instead, I'm going to show you 3 examples taken from the 3 main sections of the course. Now, keep in mind, each one of these sections is divided into a number of subsections. So these examples are only a small fraction of what you'll be able to do once done with the course, but I think they'll work really well to give you a taste of what you'll be able to achieve once done. Now, since this is just a teaser, don't worry about how these programs work. We will cover how to write these programs in details. So for now, just sit back, watch the lecture and enjoy it. And then once you start the course, you will learn how to write all of these programs and much, much more. In the first example, I'm going to use 2 on the same network. We'll read this data and filter it to show us usernames, password, and so on. We're going to run Scratch. Now these programs are running on the target machine and try to generate traffic and maybe log in. I'm going to go to hotmail.com and let's try to sign in. I'm clicking in and I'm just going to put some sample information. So I'm going to put a username and the sample password and I'm going to hit enter. And now the hacker machine, you can see that first of all, I can see all request websites they're visiting, and I can also see the username and the logged in with. So I can see the username was zaid22@hotmail.com and I can see the password was 123456. Example that I'm going to show you is a backdoor. A backdoor is a program that when executed on a system, it allows us to remotely control that system and gain full control over it. Now, just like all the other tools, we're going to program this from scratch, and I'm going to show you how to write this in a generic way so that you can use the information you learn here in many scenarios. For example, you'll be able to write for a chat program and so on. Here are an executing and waiting. The backdoor gets a computer, you get a connection will be all the features in this backdoor will implement. So system cd, it will show directory, and as you can see, users need downloads, basically because the backdoor is actually stored in this location. So do cd, and if do cd, you can see I'm in Zaid. Execute all system commands. Backdoor works on all operating Windows and OS X. So target is Windows. So if I wanted to there, and as you can see, I get a list of all the files working directory. Now I can go back in downloads by doing cd downloads, and if I list again in here, you'll see the file the downloads, which are the backdoor and the GTR image, which I have. Now I also want to highlight a feature that we're going to program, which is the ability to download files. So I'm just going to add the file name that I want to download, and it's dgr.jpg. And as you can see, I'll see it automatically being downloaded in here. And if we double click this, we have the image in and able to open it. Now I'm downloading the image just as an example to show you that you'll be able to download any file the target system. You can also upload, which is really, really useful. Upload services, keyloggers, and so on. And as an example, I'm just going to rename this image to gtr2.jpg, and I'm going to upload. So I'm going to do upload g or .jpg. Now it's telling me the upload successful, and if we go here again, you can see we have the new image. Now, because you're able to execute system commands from the backdoor, you'll be able to get from here and execute it remotely on the target. The last example that I want to show you is a vulnerability scanner that can automatically discover weaknesses in websites and web applications. So all you have to do is just give this program it's going in the target website. Then it's going to extract all the parameters. Finally, for each one of these parameters and forms, it's going to submit code to discover vulnerabilities. Then, once it's done, it's going to show the results. And as you can see, it was able to discover an XSS vulnerability in here. Just like all the other programs, we're going to write this from scratch. So again, don't worry about how this works, and don't worry if you don't understand what a vulnerability is and all of that. We will cover all of this later on in the course. Now, like I said, the course is going to be highly practical, so I want to teach everything by example. Therefore, we're literally going to start programming without even covering Python basics. We're going to cover the basics as we write our first program. Now, the first program that I want to write is going to be a MAC address changer. MAC address stands for Media Access Control. It's a permanent physical and unique address assigned to network interfaces by the device manufacturer. So whether you have a wireless card or a wired or Ethernet card, each one of these network cards come with a specific address that is unique to this card. So there is no two devices in the world that would have the same MAC address, and this address will always be the same to this specific device. Even if you unplug it from your computer, connect it to another computer, then this network device will always have the same address. So you might already know that the IP address is used in the internet to identify computers and communicate between devices on the internet. MAC address is used within the network to identify devices and transfer data between devices. So each piece of data or packet that is sent within the network contains a source MAC and a destination MAC. Therefore, this packet would flow from the source MAC to the destination MAC. So, because this is a physical unique address to each interface, to each network device, and because it is used to identify devices, then changing it will make you anonymous on the network. Not only that, but the MAC address is often used by filters to prevent or allow devices to connect to networks and do specific tasks on the network. So being able to change your MAC address to another device's MAC address will allow you to impersonate the device and allow you to do things that you might not be able to do. So you'd be able to pass filters or connect to networks that only specific devices with specific MAC addresses can connect to, and you will also be able to hide your identity. Now, changing MAC address is very simple. Let me show you how to do that manually, and then we'll see how we can write a program to do that card. So right here we have ETH0. This is a virtual interface. It is created by VirtualBox because to use a NAT network. So remember when I said this computer thinks it is connected to it, and you can see it says this is done through a virtual network and a virtual interface network. You can also see the LO, which is a virtual interface, and IO, which is an external USB. So you might not have LAN 0. It's okay. Unless you want to run some of it, we will do later on against our listener. Don't worry about it now. We'll talk about it later. Now, other than the interfaces, the ifconfig command also lists about each one of these interfaces. So you can see is connected to a network. You'll see it has an IP. You see this because it is not connected. You can also see that mask the browser. Also see the MAC address. So right now, the MAC address for ETH0 is the highlighted. 0, we have the MAC address in here. Now to change this MAC address, we're going to do ifconfig, followed by the name of the interface we want to change its MAC address. So if you want to change the MAC address of ETH0, you do ETH0. If you want to change the MAC address, you would do. Now in this example, I want to do it for ETH0 because everybody will have ETH0 wireless 0. So I'm going to do it for ETH0 so that everybody can follow this. Then I'm going to type down to disable. So this is the step. We're going to disable our interface. And if you don't see any errors, that means the command properly. Now that the interface is disabled, we can modify its options. And the modify is the ether, which is the MAC. Ifconfig, again, put the name of the interface that you to modify ETH0, and we're gonna say HW and specify the new MAC address that you want. You can use any MAC address that you want, and for example, I'm gonna use 011233445. So make sure it is 12 characters. Make sure you split it using the command, and that's it. So I'm gonna hit enter, and so that means the command got executed properly, and is enable the interface because we disabled the command. To enable the interface, we're gonna do ifconfig interface name, and I'm gonna say up to enable it. So we do down to this and up to enable it. Error, so that means the command got executed properly. And the last thing that is do ifconfig again to see if the MAC address did actually. So I'm gonna hit enter, and as you can see now, if we look at of ETH0, you can see that this has been changed to 0123445. So as you can see, it is very useful in so many scenarios. And why I'm showing you how to change it manually is because I want you to understand is how to change it, and then in this section we're going to write automatically change the MAC address for us. Okay, now that we refactored and cleaned up our code, we're ready to go ahead with the next two steps, which is first of all check if the current MAC is the MAC the user requested, and then print an appropriate message. Now we're going to combine the two steps in this lecture today because they are very easy and we've actually used everything that I'm going to do now in the past, so it should be easy for you to understand. Now first of all, I'm just going to hide this block right here because we don't care how we get the current MAC. We just know that we have a function that gives us the current MAC. And right here we have the code for our main program. And we know now this current line right here is going to get me the arguments that the user enters. Then the next line right here is going to get me the current MAC using the getCurrentMac function that we wrote in the previous lecture. Then we're going to print the current MAC. And then this is the step where the MAC address is going to change. So I'm actually going to uncomment it so it gets executed. And this is all going to be done using the changeMac function that we wrote before. So this line right here, we'll call this function. It will send the options.interface and options.newMac, which is the interface and the MAC that the user enter as arguments. So far so good. So after this step, the MAC address should change to the MAC address that the user requested if everything goes smoothly. So after this line, we need to check if the current MAC is actually the same as the MAC that the user requested. To do this, first we need to get the current MAC again. So we're just going to do current MAC equals get current MAC, and we're going to give it options.interface. So this line is identical to this line, and both lines do the same thing, just get the current MAC. Keep in mind I'm using the same variable name in here, which means that whatever value that was stored in the variable before will actually get changed now if the MAC address did get changed. Now that we have the value of the current MAC stored in the current MAC variable, all we have to do is use an if statement, and we're going to check if the current MAC is equal to the MAC that the user requested in the arguments, which is stored in options.newMac. If they are equal, then we're going to print MAC address was successfully changed to, and I forgot an L in here. Now in here you can either print the options.newMac or current MAC, doesn't really matter because it got changed. Otherwise, so we're going to do else print MAC address did not get changed. So one thing that I want to note here, see in here I actually used equals equals instead of a single equal. In Python, when you're comparing two values, so we're comparing the current MAC and the options.newMac, if you want to check if two values are identical or equal to each other, then you have to use equal equal instead of a single equal. Because as you've seen before, when we use a single equal, Python thinks that we want to assign a value to the variable. For example, when we wanted to capture the value of the arguments, we said options equal to get arguments. We want to capture the current MAC, which is the value returned by the getCurrentMac function. We say current MAC equals getCurrentMac. So if you don't want to change the value of the variable and you just want to check if the value in this variable is equal to the value in this variable, then you have to use equal equal instead. Now that's it, our code is done. Let's go and test it. So I'm going to clear all of this and I'm going to try to change the MAC address of ETH0 to something that ends up with 22. Hit enter, and then when it's going to tell us my address was successfully to this value. Now perfectly, if it faces errors, it's going to print error messages for us. If it works well, it's going to give us a message to validate that everything worked fine, and it also looks good and very reusable because we splitted it into a number of functions. So it comes multiple times throughout the program. One thing I want to do, note the value here for the current MAC. The first time it was printed as actual MAC, and then when we use the same variable but to the function again to get current MAC. Now, since the MAC changed, here was overwritten with whatever this function returns. So if you check it again, you'll see that after it changed. It shows that you can override the value in variables as well about the program. Now that's it for this program. We can still add more features to it, but I think that's good for now. We learned how to use functions, we learned how to use decision making, we learned about Regex, how to use modules, how to execute system commands, read system output, and much more throughout this very simple program. So we're done with this. Next, we'll move on with another program where we're going to learn more concepts and build more advanced stuff. In the previous section, we built a program that will allow us to run an ARP Spoofing MAC, which will allow us to redirect the flow of packets in the network and place us in the middle of the connection between any clients in the network and the router. This means that anything that this client sends or receives will go through our own computer, allowing us to see all the passwords, all the usernames, the URLs, the images, the messages that they send and receive. So this is very, very cool. Right now we have a program that will put us in the middle of the connection, but we still don't know how to read this information. So this information is flowing through our computer, but right now we're still not reading this information and we have no way of reading this information. Now this information flows as packets, and in order to read this information, you'll need a packet sniffer. Again, Kali Linux contains a number of tools that allow you to sniff packets and read this data. And I actually cover these tools in my other courses, in my general ethical hacking course and in my advanced network hacking course. But as you know, in this course, we don't use any pre-built tools. So in this section, I want to build our own packet sniffer so that whenever we are the man in the middle, we'll be able to read all the information that flows through our computer, and we'll be able to see all the usernames, passwords, URLs, and so on that any target computer sends or receives. Now, the idea of the packet sniffer is it's basically a program that reads packets or data that flow through an interface. So, at the start of this section, we're actually going to build a program that will allow us to read the data that flow through a certain interface. Then, once we use the tool that we built previously to become the man in the middle, the data will flow through our interface by default because we'll become the man in the middle. And you'll see at the end of this section how we'll be able to read the usernames and the passwords entered by a remote computer that is connected to the same network. Now, before we jump into programming, I want to show you the program that we're going to build in action. So this is just a teaser. Don't worry about how this works. We're going to cover that in this section. I just want you to have an idea of how this is going to work. So right here, I have the ARP spoof. Let's go to the Windows machine and just go to any website. So let's go to bing.com. And now if we come back, as you can see, first of all, we can see registered as a website that the target visited. We can also see all the files that had, so the web page automatically loaded some JavaScript and we can see it here. We also see the images that have been loaded. And like I said, anything that the user is going to load through the browser will actually be captured in our sniffer. Let me show you an example of logging in to a login page. So I'm back at the Windows machine and I'm at a website called Desiccation. So if we go to the login page and put some fake information, so we'll just put an email address, test email.com, and then put any password. We're gonna hit enter. And now if we go back and scroll up in our sniffer, as you can see, it's telling me that there is a possible username password combination. The username, which was test@gmail.com, password that I entered, which was 1234567. So as you can see, this sniffer is useful. It builds up on what we did so far, ARP program, and it's going to allow us to towards your name URLs that any user does on your network, of course, after. Again, don't worry about how this works. We will build the program section. So this is just a teaser to show you what you want to achieve at the end of the section. Okay, we've been working on our DNS spoofer so hard, and hopefully it'll work without giving us any errors. Now, I've actually not tested this before recording this lecture, so it's going to be fun to see how it's going to work. I'm going to do python dnsspoof.py. I've already ran my IP tables that'll redirect everything to queue number 0, which is the one that is trapping packets here. So now, if I do ping c1 bing.com, instead of getting the IP of Bing like we were getting previously, this one, we should get the IP that I set in here, which is 10.0.2.16. So let's run this. And perfect, it's working. We got our print statement here, and we got the IP 10.0.2.16. I'm actually really happy right now. So the target is requesting to go to bing.com, and the DNS, which is supposed to give the target the actual IP of bing.com, returned a spoofed IP. And this IP is being set by us, which is the hacker. Now, let me show you just a quick example of how this can be used. So if I just go to my file manager and go to the location where my web server files are stored, and this is in var www.html, you'll see a file called index.html. This is the file that gets loaded by default in web servers. So I'm just going to modify this very quickly. I'm not really doing a proper attack. I just want to give you a good idea of what this is. So I'm just going to open this file in LeafPad. And I'm going to delete everything here. I'm just going to say, nothing really important, but this is what's going to load in my website. I'm going to quit this and run my web server that comes with Kali. So all you have to do is just service Apache 2 start. And now if I go to my web browser and try to go to bing.com, you'll see that instead of getting bing.com, we will actually get a website that is configured by the hacker. And you can see on the top, it still says bing.com. So this opens a wide array of attacks that we can do after being the man in the middle. You can give your target fake login pages when they try to log into a website. You can give them fake websites and ask them to load or to execute some kind of code. You can give them even fake updates, and I cover a lot of that in my other courses, such as the social engineering and the general ethical hacking course. But this is kind of drifting away from programming, so I won't be covering that in this lecture. What I also want to show you is how to run this against a remote Windows computer. So I'm going to close this, and the only difference is we'll need to first flush our IP tables, so remove the IP tables that we have. And to do that, we'll do IP tables flush. Again, I covered this before. And we'll use an IP table rule that'll redirect packets coming from other computers into the queue that is being used in this program. Again, I covered this before and I showed the exact command. So I'm just going to run it quickly here. And it's literally, instead of the input in here, we're going to say forward. So forward is the name of the chain that packets go through when they're coming from other computers when we are the man in the middle. So I'm going to enter. This runs with no errors, which means it got executed properly. And the last thing that you want to do is become the man in the middle. And we'll do that using our ARP spoof program that I taught before. Now I'm already in the directory of this program, so all I have to do is python arpspoof.py. And now let's go to the Windows machine and go to bing.com. And as you can see, instead of getting the actual page bing.com, we got redirected to the web server that is running on the Kali machine, and we see the content that we put in the index.html. Now, obviously, this is a very simple content, but the attack that we were building so far is working perfectly, and we can redirect any request to any domain to any other server. So this can be used to serve fake web pages, fake login pages, fake downloads, fake updates, and so many other cool attacks. If you want to learn more about what you could do with DNS spoofing, I highly suggest you have a look on my other courses, as I use that to run a large number of cool attacks to gain full control over computer systems. As you know, this is a programming course, so we're interested in the programming aspect, and to run these attacks that I'm talking about, you don't really need to program anything. You'll be using an already existing programs, therefore I will not be including them in. Now, in the previous section, we wrote a program that can modify paths as they flow through our computer, allowing us to spoof DNS requests and redirect any request to any website to another destination. And we spoke about how dangerous that is. In this section, I want to build yet another program that can be used to modify data as it flows through our computer. But previously, we were modifying data in the DNS layer. Now, in this section, we're going to be modifying data in the HTTP layer. So the HTTP layer is the layer that data gets sent through when you browse websites. So you see the http://. So pretty much everything that you see through your browser is loaded over HTTP. So we're going to have an example of modifying HTTP data. And by the end of this section, you're going to be able to adapt this to modify anything that's sent over HTTP. In this example, in this program, we're going to be modifying downloads. So when our target tries to download something from the internet, whether they're downloading a program or a PDF, for example, we're going to intercept that download and replace that download with a completely different file. This is very, very dangerous because we can intercept downloads that the target person is downloading, and whenever they want to download a program, for example, instead of them getting a program, they will actually get a backdoor or a credential harvester or a virus or any other file that you want. So, as usual, let me show you a teaser of this program. Don't worry about how this program works for now. We're going to discuss this in details. For now, just enjoy and see how this is going to work. And in the next lectures, we're going to write this program in Python and we'll cover how it works in details. So right here, I have the place downloads program, which is the file interceptor that we're going to build in this section, running alongside my ARP spoofing program that we built before. So let's go to the target Windows machine. And I'm going to go to avg.com, which is a website for the famous antivirus program, AVG. So if I click on free download to download this antivirus to protect my computer, you will see instead of getting the actual installer for AVG, we are getting a file called evil.exe. Now this is happening because we are running the file interceptor and our ARP spoofing programs at the Kali machine. So the ARP spoofing program is putting us in the middle of the connection, and the file interceptor is placing the file that the target person should get with a file that the hacker picked, which is in this case the evil.exe file. So if we click on save now, this will actually download it for me. So if I go to my downloads, you will see it right here. Now this file can be anything. It can be a backdoor, a virus, or anything that you pick. And we'll learn how to program our own backdoors key. Still, so it doesn't really have an icon. It's called evil.exe. But again, later on, I'm going to show you how to convert our malware like any other file, like an image or a PDF. So for now, for this section, I was going to be trying to build a program that will replace downloads requested by any computer on the same network as us with any other file that we want. So as we've seen in this example, the target go to iTunes or to any other website to download a normal program, and instead of them getting the normal program or book, they will get a file that we choose. In the last section, we built a program that we can use to intercept download and replace any file downloaded by any computer connected to our network with any other file. Now, this was an example of modifying HTTP packets as they go through our computer. Now, in this section, I want to give you another example of modifying HTTP packets as they flow through our computer, but in this example, instead of creating a new response like we did in the previous section, we are going to modify the data sent in the raw layer. So by the end of this section, you're going to understand how to modify anything that gets sent in the raw layer. As an example, we're going to be modifying the HTML code. One of the most important and useful things that can be sent through the raw layer is the HTML code for any web page loaded by the target client. So we're going to build a program that can be used to modify any part of any web page loaded by our target. And as an example, we're going to be injecting JavaScript code in the target web page. And we'll see why this is dangerous and how useful. Now, so far, we learned how to become the man in the middle, and once man in the middle, we learned how we can read all the data that's being sent. So we were able to read usernames, passwords, URLs, images, or anything that the people browses. We were also able to modify this data. So we were able to inject JavaScript code or any type of code that we want in the target browser when the target browses websites. This also allowed us to replace downloads and do so many cool attacks. Now, everything that we did so far will only work against HTTP pages. The reason why it works against HTTP because, as we've seen, the data in HTTP is sent as plain text. So it's text that humans like us can read and understand. That's why when we're the man in the middle, we're able to read this text, and if we wanted, we're able to modify this text as we wish. Now, this is obviously a problem, and this problem was fixed in HTTPS. So, as you know, most websites these days use HTTPS, and all good websites, famous websites, use HTTPS. The reason why, like I said, because it's a more secure version of HTTP, and basically the way it works is it keeps the implementation of HTTP exactly the same. So all the headers, all the way that the data is sent is kept the same. So HTTP is not modified, but it adds an extra layer over HTTP, which is where the S comes from. So it's a secure HTTP protocol, and this extra layer will encrypt the plain text data that HTTP sends. So if a person manages to become the man in the middle, they will be able to read this data. The data will be gibberish. It will not be readable to the person intercepting the connection. It's only going to make sense to the user and to the server because they both have the key and are able to decrypt the encrypted data. So let's have an example of what this would look like. Now, in general, when we become the man in the middle using ARP spoofing or any other method, as we know, requests will flow through the hacker. The hacker will forward this to the internet or to the access point. Then the internet, and then the responses will flow through the hacker computer and down to the victim. Now, usually, if a person or a user tries to go to a website, and let's say they try to go to bbc.com, they will send a request. Now, this initial request, will not be sent over HTTPS unless the user types HTTPS before the website. And we know most users, including myself, we don't really type HTTPS. We just type the name of the website. So if they want to go to bbc.com, they'll just type bbc.com. So the initial request is going to be sent over HTTP. The hacker, being the man in the middle, is going to receive this and forward it to the internet. bbc.com, on the other hand, is going to respond by saying, hey, why don't you talk to me over HTTPS? It's more secure. Now that the target knows that BBC can communicate over HTTPS, then they're going to communicate with BBC using HTTPS from now on. So all the requests that will follow after the initial request will be sent over HTTPS. The hacker will receive this, forward it to the internet, again as HTTPS. The server will respond with HTTPS, and as you can see now, all the communication, all the requests and the responses are sent over HTTPS. Now, like I said, HTTPS adds an extra encryption layer to the HTTP protocol. This will mean that the plaintext data that we usually read in HTTP will be encrypted, and it will be not useful for us. So now that we are in the middle, we're able to see all this data, we're able to read, but this data will be gibberish. It will not be readable, and therefore we won't be able to see the usernames, the passwords, the URLs, or the HTML code. So we won't be able to inject code or modify these packets because we can't even read them in the first place. Now, this is really bad for us as a hacker because we did all the hard work of trying to become the man in the middle, and once we're the man in the middle, we're not able to make use of this very good position. Luckily, there's a smart guy called Moxie who has been defeating SSL for a very long time, and one of the ways that this guy came up with allows us to bypass HTTPS and downgrade it to HTTP. Now, Moxie didn't only discover this attack, he also wrote a great tool that will do this for us. So the way this will work is, let's have a look again on the initial request. And like we said, usually people don't type HTTPS when they request a web page. So they'll type, for example, bbc.com. This will go through the hacker computer who is already the man in the middle, and is also running a tool called SSL strip, which is the tool that implements Moxie's attack. Now, the tool is going to see that this is a HTTP request, so it's not going to play with this is good for us as a hacker, and it'll just forward it to the internet. Next, bbc.com is going to respond by saying, hey, why don't you communicate with me over HTTPS? Now, SSL strip is going to detect this. And by the way, when I say BBC is going to say, hey, why don't you communicate with me over HTTPS? The process is actually a little bit more complicated than this, but I'm just trying to keep it as simple as possible. So, SSL strip is going to detect that the server is trying to tell the target to communicate over HTTPS, and it's going to remove or strip all the fields and all the data that's basically saying, let's upgrade this connection to a HTTPS connection. So the response is going to come as a HTTPS response, but SSL strip is going to strip that and only forward the parts that look like a normal HTTP response to the victim. Now, so far the victim doesn't know that the server can communicate over HTTPS, therefore it'll send its next request as a normal HTTP request. Now here's where SSL strip is smart, because it's going to keep track of all the websites that have sent a HTTP response. So even though the victim is going to send the HTTP request when it's communicating with bbc.com, SSL strip knows that bbc.com likes to communicate over HTTPS. So what it's going to do is, once it gets a HTTP request from the victim or the target, it'll actually upgrade that connection to a HTTPS connection. So, as far as bbc.com is concerned, it told the target that you should communicate with me over HTTPS, and the target responded by starting communicating over HTTPS. So this is perfect for bbc.com, and for the victim, as far as they're concerned, they don't think bbc.com can communicate over HTTPS, because every time they send the HTTP request, they are getting a HTTP response. So they don't think that BBC can communicate over HTTPS, because if it can, then it'll respond to the victim saying, communicate with me over HTTPS. Now this configuration is perfect now, because us as a hacker were able to read the requests and the responses in plain text. And nobody knows that we are playing around with the connection. The target thinks that the website that they're trying to access only supports HTTP, and the web server is happy also because it's communicating over HTTPS with what they think is their client, but who they're connecting with is actually us. Now we're able in here, when we get HTTP responses from the internet, we're actually able to read them because we are the ones initiating the HTTPS requests. So you can see the HTTPS cycle is actually only between us and the internet or the web server, and it's not between the victim and the web server. Now another thing that SSL strip will do is when it loads a web page, it will actually convert all the links in the page from HTTPS to a normal HTTP. And this way, when SSL strip is working, all the HTTPS connections will be downgraded to HTTP. Now, since the connections are going to be downgraded to HTTP, that means the data is going to be sent in plain text, which means that we'll be able to read and modify this data just like we usually do with HTTP. Now, there is one exception to this whole rule, which is websites that use HSTS. Now, HSTS is used by Facebook, PayPal, and Gmail, for example. And basically, the way this works is the browser at the victim, at the target, comes up with a hard-coded list of websites that it should only load as HTTPS. So even if we try everything that we can and try to downgrade this connection to a HTTP, the browser will just refuse to load this page because it knows that this page has to load over HTTPS. Now, so far there isn't a practical way of bypassing HSTS. There was, but that got fixed. But I will update you as soon as there is a new way to bypass. This is going to be fun. In this section, we're going to start programming malware. If you think of it, keyloggers, viruses, and backdoors are programs that carry out a specific task. For example, a backdoor is a program that solves the problem of allowing you to gain access to a target system. So writing malware is really just writing evil programs. In this section, we're going to start by writing simple but powerful evil files. Files that will allow you to download and execute code, execute and report the result of code, and so on. You're going to learn how to combine all of these files together to run powerful attacks and gain access to systems. Once done with that, we're going to move to writing more complex evil programs. We're going to write a program that can record every key strike entered by the target and send it to our own email. This is known as a keylogger. So we're going to write our own remote keylogger. We'll also write a program that when executed on a target system, it'll give us full control over that system. This is known as a backdoor, and you guessed it, in this section, we're going to build our own remote backdoor. Not only that, but by the end of the section, I'm going to show you how to convert all of these evil files into Trojans so that they look and function just like any other file type, like an image or a PDF. All of the evil programs that we're going to write in this section will work against all operating systems, against Windows, OS X, and Linux. Not only that, but they'll also bypass antivirus programs because they'll be. Now, in the next lectures, we're gonna start writing our own remote keylogger. A keylogger is a program that records all key strikes entered on the keyboard. Now, from this description, you can probably see how useful this can be because it's going to register everything that the user typed on their keyboard. So you're going to be able to see the usernames, the passwords, chat messages, emails, anything they type really. Now, there are two main types of keyloggers. We have local keyloggers. These are keyloggers that will store the entered keys in a specific location on the target computer. And we have remote keyloggers, and these are more useful in my opinion because they will send you reports of the entered keys to your own email account or to your own server. So we're going to be building a remote keylogger, and as we do this, I'm going to teach you about recursive functions, threading, and object-oriented programming. Right now, I just want to show you a teaser of the program that we're going to build. So as usual, don't worry about how this is working. I will cover how this works in details in the next lectures. For now, I just want you to see what we're going to build and get an idea of our goal. So right here, I have the target Windows machine. This is the machine that we want to spy on. And I have the backdoor right here called zlogger. Now, I know this still looks a little bit suspicious, but don't worry about this. We will cover how to convert this file and similar files to Trojans so that they look and function like any other file types like images and books. But for now, I just want to give you a teaser on how this keylogger will work. So I'm going to run it right now. And we're getting a warning message that you always get in Windows when you run exes with an unknown publisher. So this is normal. We're just going to say run anyway. And this should run the backdoor for me in the background, logging every key strike entered by the user. So literally anytime they use the keyboard, the key strikes will be logged by my program and they will be sent to me by email. So let's go ahead and try to type some key strikes and test it. So let's go to Facebook. And let's put a username as Zaid. And let's put a password as password for Facebook. Okay, we'll hit enter, doesn't really matter. Now let's go to my email and see if the keylogger worked. And as you can see, we got the first email, which basically telling us that the keylogger started. And then we will start receiving reports based on the time interval that we set in the keylogger. And perfect, as you can see, we got a report here. If we open it, you'll see that the user typed facebook.com, hit enter, put a username which was Zaid, and then put a password which was password for Facebook. Now this is just an example. Like I said, this will record anything that the user types using their keyboard. And again, don't worry about how this works. We will cover this. Okay, now in the next lectures, I want to start building our own backdoor. A backdoor is a program that when executed on a system would allow us to gain full control over that system. We're going to implement this using sockets, and you're going to learn how to establish a connection between two devices and transfer data between them. This is very useful because it can be used in so many other scenarios other than hacking. So you can use it to create a web server, a chat program, and so on. Then we're going to build more cool features in this backdoor so that we can use it to execute system commands remotely on the target computer, download, upload files, and maintain our access even if the system restarts. I'm going to cover how to do all of this in details in the next lectures. But before we start programming, as usual, I'm going to give you a quick teaser on how this backdoor will work by the end of this section. So don't worry about how this is working. I will cover that in detail. But for now, I just want to show you how this backdoor will work so that you have a general idea of what I'm trying to achieve by the end of the section. Okay, so right now I'm in my attacking designer program. Again, I'll to program. And on my Windows machine, I have the backdoor already converted to an exe. Again, we'll cover that later on. And again, it looks suspicious, but focus on getting a backdoor that works. And we'll talk about making this look less suspicious and how to make it look like any other file later on in the course. Execute this by double-clicking it. This will execute the evil code, which will mention between this computer and the hack computer. And I can see right now that I get a connection. So now all the features allow me to do, and I'm just going to show you all do with it. So first of all, I have access. So if I do cd my current working directory, and as you can see, I'm in users. That's basically because the backdoor is in location. So I can do cd back one directory, and if I do cd now to see where am I, and see, and we can also execute all system commands. That works on all operating systems. It works on Linux, Windows. You can use the system commands of your target, and they will work by default. It is Windows. So if I wanted to list the directories, I can do dir. And as you can see, I get a list of all the files and directories in the current working directory. I can go back in downloads by doing cd downloads. And if I list again in here, you'll see the files that we have in the downloads, which are the backdoor and the GTR image, which I have right here. Now, I also want to highlight a feature that we're going to program, which is the ability does. So I'm just going to do download and I'll name that I want to download, and it's the image. So it's GTR. As you see, I'll see it automatically being downloaded. If we double click this, we have the image intact and we're able to open it. Now I'm downloading the image just as an example, but it just goes to show that I'm able to load any file from the target system. You also is really useful because you'll be able to upload evil files, viruses, keyloggers, and so on. And as an example, I'm just going to rename this image to JPG, and I'm going to upload it. Upload gtr2.jpg. Now it's telling me the upload is successful, and if we go here, you can see we have the new image. Now, if this was an evil file, because it to execute system commands from the backdoor, you'll be able to just call it from here and execute on the target computer. Now, I'm also going to show you how to make that so even if the system restarts, it will automatically connect back to boots. Now, these are a lot of features. You're actually going to learn a lot of concepts as we write this backdoor. So don't worry about this. I know it sounds a little bit complicated, but we're going to break it down as usual, and so that it'll make sense to you and you'll be able to use the concepts that you learn here in scenario and in any other program. All the Python programs we wrote so far, except for the Mac changer, don't rely on any operating system specific functions. This means that these programs will run on any operating system as long as this operating system has a Python interpreter. So the only limitation that we might face when we want to run our Python programs on targets is if the target does not have a Python interpreter. Another problem that we might face is we've seen all the programs we use so far, we had to run them from the terminal or from the command line. Now this is fine if your program is a normal program and the user is okay with running your program, but it gets hard when you're trying to send a backdoor or a keylogger and you're trying to social engineer your target into running your evil file, and this file has to be executed from the command prompt. So you can't really tell the user to open a terminal and run the program from there. That will definitely make them suspicious. So in this section, we're going to talk about packaging. I'm going to show you how to convert a Python program to a binary executable so that it can run on any operating system, even if the target system does not have a Python interpreter. This executable will also be executed if the person double clicks the file, so they don't need to open a terminal and run it from terminal. Not only that, but I'm also going to show you how to bypass antivirus programs and convert our evil files to Trojans so they look and function just like any other file type, like an image or PDF. Now, I'm going to show you how to convert our Python programs to executables that work on any operating system. But one note to keep in mind is when you're trying to create an executable for Windows, then it's best to create this executable from a Windows computer. If you're trying to create it for Linux, then it's best to package your Python program from a Linux machine. So basically, to avoid all issues, it's best to package your Python program from an operating system that is the same as the target operating system. I'm going to show you how to package from Linux, Windows, and so on, but like I said, it's best to package from the same operating system as the target operating system. So let me show you a quick example of something that you're going to be able to achieve at the end of this section. Right here, I have a backdoor that we already know how to make, but as you can see, it looks just like a PDF, and if we double click it, it will actually show us something that the target is expecting, so a book. But if we go back to the Kali machine, you'll see that at the same time, our evil code got executed in the background and basically giving us the. In this section, we're going to start talking about website hacking. Now, website hacking is a really big topic, and I actually have a full course on that. But in this course, we're going to focus on the topics that are related to programming. So first of all, we're going to learn how websites work, the technologies used, the requests and the responses, and then we're going to learn how to communicate with websites from our Python program. Once done with that, we're going to start writing some useful information gathering tools. We're going to write programs to discover files, directories, subdomains, and a program that can be used to map the whole website and discover all the links within a target website. We're also going to write a program that can be used to guess login information in any login page. As we do this, analyze it and extract the useful. Finally, we're going to build a generic vulnerability scanner. It's a program that takes a website as an input and scans the whole website for weaknesses and vulnerabilities. Once done, it's going to show a report of all the discoveries. And we're going to this program in a way so that it can discover any type of vulnerability. With this, you're going to learn more about object-oriented programming and how to structure your program in a way so that it can be easily extended. Now, all programs in this section will work against real websites, and as a proof, I will some of them against my own website. But I do not give permission to anybody to run these programs against my own website. It is illegal against other websites, so make sure that you only do it against websites that you own or websites you have. If you don't have any websites that you own or have permission to test, then I'm going to show you how to install a vulnerable web application. So target programs that we're going to write against. Now, actually, virtual machine called Metasploitable, which comes with another all web applications that you can use to practice hacking and practice everything that we're going to do in this section. So Metasploitable is another Kali. You can think of the opposite to Kali. So Kali is designed so that you can hack into other devices. Metasploitable is designed so that you hack. It was designed for people to learn penetration testing. It is designed so that it has abilities, and we're going to use Kali Linux in order to hack Metasploitable. You can download this from the following link. You will end up like this one. So, sorry, not this one, like this one. So you compress it, you'll get this directory. Double click it, and you'll see the files. So we're going to create a new machine here in virtual machine, and I'm going to call it Metasploitable. And this is going to be a Linux machine. And I'm going to hit continue. I'm only going to give it a gigabyte of RAM, should be enough. And then I'm going to use Kali Linux. We created a new virtual hard disk. We're going to use an existing one. The reason for that is because the image right now is actually for VMware Player. So what we're going to do is we're going to put the hard disk file or the hard disk image in here so that we're going to install it the way we installed Kali Linux. So we're just going to use an existing virtual hard disk file, and I'm just going to navigate to select what I'm going to go into the Metasploitable directory, and I'm going to select the vmdk file. So it's this file right here. I'm going to click open and create. So we're going to start this machine now. Okay, so the machine is run now. It's completely installed. You don't really need to install anything. We just imported a installation, a ready hard disk. So it's asking me for the username, and the username is msfadmin, and the password is the same, so it's msf. Now note, when you type the password, you will not see it on screen. This is a feature so that people cannot see your password. So just make sure you put admin similar to the username, hit enter, and it'll let you in. Now, this is a machine only has a terminal, as you can see right now, and it's giving you a warning. You should expose this machine external internet connection because it is designed to be vulnerable. Now, right now, it's only inside our lab. It's only inside a virtual machine, so literally inside our lab can access it. So this is a really good way of using it. Now this is it. The machine is installed. As I said, in the future, we're gonna talk about how we're gonna try and hack into this machine. Again, don't be intimidated by the terminal. We're gonna use it and we're gonna learn how to use it step by step. So at the moment, just have this installed, and we're gonna move on to the next step, and we will talk about how to use it in the future. So if you want to turn off this machine, all you have to do is just type in power off and enter. And it's telling you that you need to be root. So again, I'll talk about this later. For now, sudo power off. So run the command like this. And it's asking for the admin password. That's it. It's going off now. And here we go. The machine is